So we'll try an example on this first derivative test. I'm actually going to edit the question a little bit and say find the intervals on which the function is increasing or decreasing, and then we're also going to find the extrema, the mins and maxes, just to practice the rest of our first derivative test. So first derivative test, we obviously are going to need the first derivative, so we'll start with that. We'll find the first derivative. I'll do the power rule, so that would be negative 5x to the fourth. 4 times 5 is 20. 20 divided by 2, that would be positive 10 cubed. Bring the 3 down. 120 divided by 3 would be 40. 40x squared, and then 5 goes to 0. Here's my first derivative. In order to make this as streamlined as possible, I want to find the critical numbers. Okay, so find critical numbers. Cn is critical numbers. And the reason that critical numbers are important is if I find my critical numbers, those are my possible mins and maxes, and I only have to test one number with my first derivative test between each min and max. So if you find critical numbers, then you're decreasing the amount of testing that you have to do. If you don't find critical numbers, how do you know where to test numbers and when you'll see a change in direction? So the critical numbers are where we may see change in direction. And I say may because it's not guaranteed. May see change in direction. Okay, so we'll find our critical numbers. I set it equal to 0 and I'm going to solve. I have to factor out the greatest common factor, which would be negative x squared. That leaves me with x squared minus 2x minus 8. I can continue to factor this quadratic expression in the middle. X minus 4, x plus 2. So I get 3 critical numbers. I get one at 0, I get one at 4, and I get one at negative 2. So those are my critical numbers. They are my possible min and maxes. I don't know for sure if they're going to be mins and maxes. I have to see that change in direction before I can guarantee that it's a min or max, but something special is happening at these spots. How I'm going to organize my testing is I'm going to do a table, and my table, since I have 3 critical numbers, I'm going to put in 3 dividers. So 1, 2, 3, and at the top of each divider I'm going to put my critical numbers. So my lowest is negative 2, middle is 0, highest is 4. The end of my table is going to be negative infinity and positive infinity. These are my sections of my graph. From negative infinity to negative 2, something's happening, either increasing or decreasing. From negative 2 to 0, something's happening. 0 to 4, something's happening. 4 to infinity, something's happening. So because these are my critical numbers, I know that these are the intervals where I have something happening, and I only have to test one number in each interval. I don't need to test multiple numbers because every number that I check would have the same result. So you have to pick x values in the interval. So pick an x value between negative infinity to negative 2. You can pick any number you want in that interval. I'm going to pick negative 3. Then pick a number between negative 2 and 0. Pick negative 1. Pick a number between 0 and 4. I'm going to pick 1. And then pick a number between 4 and infinity. I pick 5. If you pick different numbers than me, that's fine. Your testing will work out the same. These are my choices because these are my critical numbers. Now I'm going to do my first derivative testing. And that means you want to know what is the first derivative at negative 3. Is it positive or is it negative? So what I'm going to do is take negative 3 and I'm going to plug it in. My first derivative is here, or it was here, or it was here. You can plug it into any of these versions of the first derivative. I prefer to plug it in here because I think my numbers are easier. So I'm going to take negative 3 and plug it in. Negative 3 squared is 9. 9 times negative 5 is negative 45 times negative 3 minus 4 would be negative 7 times negative 3 plus 2 is negative 1. So if I take negative 3 and plug it into the derivative, I get negative 45 times negative 7 times negative 1. I don't know what that is off the top of my head, and I don't have a calculator on me, but I do know negative times negative times negative would be negative. Okay? And a negative number is when f prime is less than 0. What do we have if it's negative or less than 0? It is decreasing. I'm going to draw a picture of a decreasing graph. So that means my graph from negative infinity to negative 2, because when I plugged in negative 3, I got a negative derivative, is decreasing on that interval. I'm going to repeat the process for these three numbers. So I'm going to plug in negative 1. Negative 1 squared is 1. 1 times negative 5 is negative 5. Negative 1 minus 4 is negative 5. Negative 1 plus 2 is 1. Negative 5 times 1 is positive 25. I'm not even going to write the positive 25. I'm just going to write positive because that's what matters. Positive means f prime is greater than 0. Positive derivative means it's increasing. All right, got to repeat 2 more times. I'll plug in 1. If I plug in 1, I get negative 5 times negative 3 times 3. I got a positive number there. That means my first derivative is greater than 0. That's another increasing. Kind of unexpected. You usually see a change in direction, but it happens that we sometimes don't. And we'll plug in a 5. 5 squared is 25 times negative 5 is negative 125. 5 minus 4 is 1, and 7. So negative times positive would be negative. That means the derivative is less than 0. That means it's decreasing. It's going down. So what I have here is a function that is decreasing, and then increasing, and then increasing, and then decreasing. I'm going to pause the video, and I will start the summary of this answer to this question on the next video.